Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the three-phase induction motors, their construction, working, and their advantage and disadvantages. Normally, it works on the principle of electromagnetic induction and Lenz's law. So it is like same like an induction motor. It is a one of the type three-phase which we are using. That's why it is known as a three-phase induction motor. They runs at a essential constant speed from a no load to full load, which means the speed is constant whether it may be a change in load. If the speed is depend only on your frequency, which means the voltage frequency in the same ratio, if it get changed means automatically your speed of the motor will also be changed. So these motors are not maximum adapted to your constant speed. Then this three-phase induction motor doesn't require any additional starting drives. So as you seen in before video, single-phase induction motor which require one additional starting drive for your self-starting. So in three-phase we don't require that kind of self-starting devices. It is a automatically self-starting, normally a self-starting device only. Next, principal operation. So if a three-phase in supply is given to your input, which means the input in the sense stator end, a magnetic field is produced and which rotates at the synchronous speed at your stator windings, which means your field winding. The rotating flux passes through the air gap and cuts the rotor conductor which are at rest. So the rotor winding is short circuited, therefore the current will flow in a rotor winding due to the induced EMF, which means that is your electromagnetic induction principle. And magnetic field is set up in your rotor. So we have a rotating magnetic flux and another one magnetic field produced by your rotor. So these two magnetic field will get interact and a torque will be produced in it. So according to the Lenz law, under the influence of this torque, the rotor starts rotating in the same direction as the rotating magnetic field. Then coming up to the construction, it has a major two parts. One is your stator and second one is your rotor. Stator in the sense your stationary portion, which is consisting of a steel frame which encloses a hollow cylindrical core made within a thin laminations of your silicon steels. These laminations of thin shields were provided to reduce your hysteresis and eddy current losses. Then the rotor is your rotating part of your motor. So this rotating part is connected with your load end and shafts. It consists of a shaft and a hollow laminated core having a slots on its outer periphery. In here, the rotor is subdivided into a two major types according to their structure wise. One is your squirrel cage rotor and second one is your slip ring rotor or a wound or a face wound rotor. The frames next other parts of your three-phase induction motor frames. This is made up of a close grained alloy cast irons. This is your outer covering of your motor. Then stator and rotor core. This is built up of a high quality low loss silicon steel laminations and flash enameled on both end. Then stator and rotor windings. This is a moisture proof and made up of a copper or a aluminum metal. Maximum it will be a copper metal, and it is varnished and enameled by a mica sheets. Then air gaps. The air gap is will be provided between your stator and rotor. Then shafts and bearing. Normally it is connected with your rotor end and to your load. So this is main reason for your rotating of your motor. Then fans are given in our rotor side in order to reduce the heat losses in your rotor. Next we will see one small example. This is how the three-phase induction motor looks like. So the outer covering is your frame area and inside is alignments will be provided. So this is how the part wise the three phase induction motor looks like. So the outer covering and the fan covers, fans blades will be provided at your rotor end, connected with your rotor end in order to reduce your heat. Then your bearings inside your shaft which the bearing will be connected. Then your stator winding and the stator portion and the rotor windings and the rotor portions are being given. So the three phase supply will be connected at your terminal box, inside which the three phase input cables will be there, which we will connect with your stator windings and stator cores. So these are all the major parts of your three phase induction motor. Just have an overview of it. Next, coming up to the main advantages of your three phase induction motor. So it is a simple in structure and also it is cheap when comparing with the other synchronous motors. Then you don't require any self-starting equipment, which means it is the three phase induction motor itself a self-starting equipment, so we don't require any additional self-starting equipment for it. Then the efficiency and the power factor will be a good high and a reasonable thing for the cost. And the maintenance of your three phase induction motor is a very requirement is very less comparing with the other type of motors. Then disadvantages of your three phase induction motor. So as you know, it is essential for a essential to maintain a constant speed, means we maximum we don't recommend this three phase induction motor, because it is frequently changes with the frequency and the voltage of your input which we are getting. So automatically if the load get it is also a load dependent. If your load is higher, means automatically your speed of the induction motor get reduced. So next is you are very sensitive to fluctuations in a supply voltage. So automatically, as I said in before point, same thing. Then separate starter is required for a higher ratings. So as you know, for a higher level of rating we may require additional starters in order to maintain a proper input level of your three phase induction motors. Then it takes a large current from a line at an instant starting. So automatically the initial starting torque is higher, means your load will also be higher in your three phase induction motors. Next few applications of your three phase induction motor, it is mainly used in your steel mills, lifts, crane machines, hoist, line shaft, then pumps and submersibles, then for your printing machines, lathe machines, grinding machines, conveyor belts, floor mills and compressors. And all a few example of your three phase induction motor, and in most of the area we will use this kind of motors only because of their cheap and easy maintenance policy. These are all the main basics of your three phase induction motor. Hope you understand. I think so. See you in next video. Have a nice day. Nandri Vanakkam.